example 11, right? That's where we left off yesterday. Okay. Yes, I'll turn on the flashlight. Thank you for coming. We left off on 8? Yeah. What? Alright, we'll start back at 9 then. That way we will, we didn't do 8? Okay, we'll start at 8. Alright, it's okay. We got time. The last part of it, from 11 on. Alright, oh, this one's a fun one. Alright, it's a good thing I'm not going over homework, because now you should be able to do all of the problems. Okay? If this, no, we're not skipping it. It's been a long while since we've seen this algebra. Okay? This right here, if I use that as my u, it would be 2x, right? Which is not my numerator. And if I use my numerator, it would definitely not be my denominator. So what I have to do when I'm in this situation, the exponents match, but the exponent on the top is bigger. Start with long division. Way back to like the beginning of last year. We don't use it very often, but it is a good little trick to help us with integration once in a while. Okay? And you typically see it when we have the logs, because it'll eventually have a remainder and have something in a denominator. Okay? Alright, so how many times does x squared go into x squared? Once. Okay, then I multiply it out. 1 times x squared is 1 times 1 is 1. And then remember, what do we do to the signs here? Flip them, right? Subtraction. Okay. The x squareds are gone. I'm going to drop down the x. And what is 1 minus 1? 0. Now, remember we had remainders. And the remainder, you take whatever you have left, because I can't divide x squared into x. Okay? Put that on the top, and whatever you divided by goes on the bottom. So that's what we are going to integrate. So we're integrating 1 plus x over x squared plus 1 dx. Okay? Now, I would probably split that into 2 separate integrals, so I throw a dx here and an integral symbol there. When I integrate 1 dx, what do we get? X, that's not so bad, right? Better than what it was originally, for sure. Here we probably do want to use sub. I'm going to do my use sub work down here. So what's my going to be? X squared plus 1 du equals 2x dx. What's missing? Gotta move the 2, okay? Du equals x dx. Alright, let's sub it. Alright, so for the x squared plus 1, what are we putting in? U. For the x dx, we are putting in 1/2 du, and then I'm going to have the 1 to the top. Alright. Dropping down the x plus 1/2, and I integrate 1 over u to get the actual log, absolute value of what? U plus c. Could I just go ahead and put my I'm going to subtract 1, and now I've got an x equals 2. Now I can take this piece and plug it into the x up here. So it's u minus 1. Okay, and then there's another piece to this that we haven't seen yet. All right. Then what I'm going to do is I'm going to split this into 2 separate fractions. So there's got to be a natural log piece in here somewhere that would put this in, right? So u over u squared minus 1 over u squared du. Really, I should have practiced it. All right, u goes into u squared, right, like that. 1 over u. There's my natural log piece, right? And this I would probably bring this upstairs by doing what? Negative x. Good. Alright. So we've got, I'm going to keep my u's this time. Alright, when I integrate 1 over u, what do we get? Natural log absolute value u. And who wants to sub it for u? Alright, I add 1. We get u to the negative 1 divided by negative 1 plus. So you okay, all of this next step, I'm going to clean it all up and get my u sub in. Okay? Alright, so this easy, plug in your x plus 1, right? So 2, a big parenthesis still around the whole thing. Natural log absolute value of x plus 1. For this piece, the double negative is going to go what? Positive. And then where's this term going to go? To the bottom. So I have 1 over whatever the u is. And I'm going to go ahead and plug the u in, all of that one stuff. Let's see. Okay, it says solve the differential. We've seen these before. This is actually a really great u substitution. This is a really traditional problem that comes up. Okay, so this is a good one to make sure you're paying really good attention to. First thing I'm going to do is move that px to the other side. Recheck this differential notion. And actually, I'm going to rewrite it a little bit differently. I'm not going to just rewrite it the way it looks, okay? So I can help you see it. Right, it is 1 over x. Same thing, I just took the fraction part, right? Alright, we throw our integral symbols on there. You know when I integrate dy, I get y. Alright, what's your u going to be? It's going to be the natural log of x, because, right, the function is 1 over something, right? 1 over x. And then this is inside that 1 over x, which is in the denominator. So I'm going to use the natural log of x. What's the du then? 1 over x dx gives derivative of the natural log of x. 1 over x. Okay? So, let's look at substituting it. So, for this piece here, I've got 1 over u. For this piece here, for the 1 over x dx, I have all of that. So, whenever you see that x in the denominator, you should have a u sub somewhere for this. That's natural. Okay? And then, unless it's just 1 over x, there's other stuff here. Alright, and then so I sub in du for what I highlighted again. Alright. 1 over u integrates to natural log absolute value of u plus c. This is like one of my most favorite answers. So for the u, what are we plugging in? Natural log x. So we get the natural log of the natural log. Not crazy. It's one of my favorites. There's one I've seen where we do the natural log of the natural log of the natural log. So I've seen that. I don't remember if it's a chain rule or if it's one of these. So I love that answer. I don't know why. Alright, let's go to the trick. cotangent. We're going to prove it right now, what it is, and then you can either memorize it or you can do it this way. Okay? So there is a tangent integral in the front cover of your book. We just have to learn it now. All right. So when all else fails at trig, we turn it into sines and cosines, right? So what's another name for tangent or sine? Sine x over cosine x dx. All right. This u sub things. Let's try u sub. Where's your u at? It's the denominator, right? Cosine x. It's kind of hard to tell, but since we're in that natural log mode, we know that the natural log is on top. So du equals the root of cosine. Negative sine x dx. So I have the sine. What am I missing? Negative has to be sine x dx. Yes. Yes. Alright, what's going in for cosine? U. Alright, and then for sine x dx, we're putting in negative du. Alright, when I integrate 1 over u, what do we get? Natural log absolute value of u plus the. Okay, I'm going to take my shortcut this time, I'll be lazy. Instead of putting u, what am I going to write? Sine x. Alright, we just proved that one. Like I said, it wasn't that bad if you had to integrate it by hand and you forgot the memorized one. Okay? However, there are more memorized ones here. So that is that chart in your notes. Okay. So, and it is, again, it's in the inside front cover of your book with all the other intervals. Okay? So there's the one we just proved. Guess what? To prove cotangent, it's about the same. Okay? We're going to just use the ones here today for our purposes. I'm not going to try to prove secant and cosecant. So when we integrate secant, and this one for some reason comes up in BC. The other ones I can honestly tell you I haven't seen much, but I know that secant one for some strange reason they like it. Okay, so it comes up. The likelihood of these guys being on your actual AP test is very slim. Okay, but it's like one of those things where they may just put one on somewhere. Okay, so it's kind of a really nice to know you can pick up that extra. It's not going to be on your response. Okay, it will only be multiple requests. So this one, like I said, and they look goofy. It's secant plus tangent, and this one's cosecant plus cotangent. But just like with all trig, secants and tangents are together, and cosecants and cotangents are together. Okay. All right. Let's take a look at example 12. Okay. We're going to probably use one of those properties that we just had. One of those rules we just got. But I do have a u. What's your u going to be? What's your inner function here? X over 2 or 1/2 x. Same thing, right? So that means that du equals what? 1/2 dx. I don't have the 1/2, but I do have the dx. So how do I move 1/2 to the other side? We multiply it, right?
What?
Right now it is division, right? The 2 is being divided. We don't care much about the 1. 2 is being divided to get that to the other side. Okay. What? Can you take the derivative? Yes. Oh. Okay. All right. So for the secant, for the x over 2, we put in u. For the dx, we put in 2. Notice I put the 2 out. Okay. I want you to look at your chart. Okay, that you just got. So you're going to practice your integrals with your chart today rather than going through the proving process every time. All right. When we integrate secant u, we get what?
Natural log of secant u
Plus tangent u plus c. All right. What are we going to put back in for c for the u's? 1/2. So natural log secant, and I can either put in 1/2 x, or I can put in, I'll do both x over 2. Same thing, right?
Let's go timers first.
Go with my timer.
Yeah, go with your timers.
Go with my timer. Alright. You sub, right? Name of the game. Pretty much always if we're integrating, we're you sub, right? It's boring if we're not, right? Okay, so what's your U this time? Cotangent, because what's the derivative of cotangent? No, derivative of cotangent. Cosecant, what's what? Look, it's right up there in the numerator, right? Cosecant squared. It's amazing how that happens, right? Alright, but it's not just cosecant squared. It's negative cosecant squared, right? Those cotangents and cosecants don't pop up that often, but we have to be ready for them. Okay? Alright, so what's missing? The negative, so we've got to move the negative to the other side. Cosecant squared dt. Alright. What am I putting in for the cotangent of t? And for the cosecant squared t dt, I'm putting in negative u, the one on the top of u. Alright, we're going to do our lazy thing. We integrate whatever you get.
Natural log of u.
Absolute dot u plus c. So instead of writing my u, what am I going to put through? Cotangent t. Alright. Let me do some trig in the next one.
Yeah.
So what? Alright, we get to 13? Okay. Alright, we don't really know that's pretty ugly. Okay, and it's definitely, you can't use a u sub on it because you don't have the derivative of tangent sitting there. Okay? So I'm going to look for something else. It's an indicator. I don't see my derivative of tangent sitting there anywhere, so I did something else. But I seem to remember from math analysis, 1 plus tangent squared is something. Look at the windows there. What is it? It's secant squared. And look at that. I can take the square root of secant squared, can't I? What's the square root of secant squared? Secant. Top on Friday, isn't it? Okay. Alright. Now go look at your new chart, right? When we integrate secant, what do we get? Natural log, good. Secant x plus tangent x. And it's not a plus c because it's definite. So 0 to pi over 4. It's been a while since we've seen pi over 4. Okay, so we've got to think about, let's see, our coordinates for 0 are here. Pi over 4 is the one in the middle, isn't it? So square root of 2 over 2, square root of 2 over 2. Right? So pi over 4 is the one that matches. I know, it's been a while for you to circle. Alright, so let's go ahead and plug in. So you got the natural log absolute value of secant of pi over sure that we would do the integration and then take the derivative of it. And that's the better way to do it. Then we take care of our shit. Alright, this last couple we're doing one example of kind of something that might pop up in the assignment. Average value, remember we talked about this in the last chapter.
Oh,
Good job, 1 over b minus a, so 1 over pi over 4 minus 0, 0 to pi over 4, tangent of x dx. Perfect. Okay, let's talk about this mess here. 1 over pi over 4. Don't I flip the reciprocal? So don't I really end up with 4 over pi? Okay. Alright, go ahead and use your chart. Let's see, I know the tangents are already proved it once. Negative natural log it, cosine x, and then we're going to go from 0 pi over 4. We're like pi over 4 today. 1, 0, 2. Okay. So we've got pi over 4 over pi out front. And then we've got negative natural log absolute value of cosine of pi over 4 minus negative natural log absolute value of cosine of 0. How can we do this double negative? Positive. Okay, so keeping that 4 over pi something out front. What is the cosine of pi over 4? Square root of 2 over 2. Absolute value of it would still be square root of 2 over 2, right? So then drop my absolute value first. Plus, what's the cosine? 0. So I've got the natural log of 1, which is good. See, you've done it so many times now, it's so common, you should really have it. Alright, if I were to clean what this looks like up, I'd probably go negative 4 over pi natural log square root of 2 over 2. Again, likely to be a non-calculator versus a calculator. If you did have to use the calculator, the number I got was 0.441. Alright, got one more. Alright, 5-6 minutes, right? Even doing more examples than I anticipated, right? Okay. We are supposed to show that these two statements are equivalent. This doesn't happen very often. This is just kind of an interesting problem, more so than something you probably see on the AP test. Okay? Remember how we did all those verifying the identities last year? It's kind of similar to that. You won't see any kind of verifying on the AP test because they can't grade it multiple choice, and they're not going to grade it first one. They do it first one. All right, so let me see where I started here. It looks like I started with, I have to basically show that this one equals that one. So they said it integrated to both of those things, right? So I'm going to start with this one here. Negative natural log absolute value of sine x plus c. We're going to use log and trig properties. Okay? What log properties allow us to take this negative exponent, right? Okay, so I really have the natural log, and it's going to look goofy. I'm not going to put it in outside the absolute values. I'm actually going to carry that negative inside. So sine x, so the negative 1 absolute value plus. Okay. Another name for sine, remember, look at where I need to go to get it into cosecant. Another name for sine. 1 over cosecant. So now I've got it into cosecant. It's not on the right level, but I got it into cosecant. Plus c.
Let's see.